Bismillahirrahmanirrahim. Topical question paper solution part 1, and the topic is DC circuits. In this session we will solve 10 sample questions. The course is Cambridge O level physics and the code is 5054. Let's start our session. Question number 1. The cells, lamps and resistors in the circuits are identical. In which circuit is the lamp the brightest? You can see A is a series circuit in which one resistor and one lamp is there. B is also a series circuit, consists of two resistors and one lamp. C is a parallel circuit. It's a parallel combination of two resistors and lamp is in series with this parallel combination. In D circuit there is a parallel series combination of three resistors and lamp is in series with the parallel series combination of resistors. Okay, the lamp will be brightest in that circuit configuration which has the parallel combination of resistors that offer the least resistance, and consequently the highest voltage will be dropped across the lamp. Okay, let's assume, for explanation purpose, let's assume the resistance of lamp is 10 ohm, value of one resistor is 10 ohm, and the electromotive force of battery is 120 volt. So for four options, the lamp resistance is constant. For every option it is 10 ohm. Circuit configuration, for option A it is single R. The effective resistance in that circuit is 10 ohm, and the voltage across the lamp is calculated using the voltage divider rule, because lamp is in series with this 10 ohm resistance and the voltage across the lamp is 60 volt. For option B, circuit configuration is still series but the effective resistance is 20 ohm, and using the voltage divider rule the voltage across the lamp is 40 volt. For option C, circuit configuration is parallel. Effective resistance for two parallel resistor is 5 ohm and the voltage across the lamp is 80 volt. And for option D, that is a series parallel configuration, effective resistance is 15 ohm and the voltage across the lamp is 48 volt. So you can see that for option C, the parallel configuration, the voltage drop across the lamp is the maximum, that is 80 volt. So here you can see the option C, that is parallel configuration of two resistors. Question number 2. Which component when used in a circuit allows current to pass in only one direction? Four options are given. Option A is diode, option B is lamp, option C is fuse, and option D is bell. The correct option is option A, diode. Diode allows the current to pass only in one direction only. If the diode is forward biased, that forward bias means its anode is more positive with respect to the cathode is negative, and its anode is more positive than the cathode. It is forward biased configuration, and in this configuration that diode will allow the current to pass through. So diode will be in conducting state in forward biased. Okay, in other configuration, for reverse biased configuration, the anode is made more negative with respect to the cathode, and in this configuration the diode is closed, and it will closed like a closed gate. In electrical term it is open circuit. Reverse biased configuration is open circuit, and the diode will not allow the current to flow. So these two configurations are possible in case of diode only. So diode is a intelligent device, and it allows the current to pass in only one direction, and that is forward biased direction. Question number 3. A potential divider consists of a thermometer and a light dependent resistor LDR. Which conditions give the smallest voltage drop across the light dependent resistor, that is LDR? Explanation is, thermistor has two resistance mode. Similarly, LDR also has two resistor mode. At high temperature, thermistor offers low resistance, and at low temperature, the thermistor offers high resistance. Similarly, LDR in brightness or bright environment, it offers low resistance, and in dark environment the LDR offers high resistance. Thermistor should be operated in high resistance mode in cold environment so that most of the input voltage is dropped across it, and the LDR should be operated in the low resistance mode in brightness so that the least or minimum voltage is dropped across it. So the correct option is cold and light. Thermistor is operating in cold, and the LDR is operating in light environment or bright environment. And in this scenario, the potential drop across the LDR is minimum. Okay, question number 4. Which diagram shows the arrangement of the ammeter and voltmeter to obtain readings to find the power of a lamp? To find the power of the lamp, we need two physical parameters. Number 1, the voltage across the lamp, and number 2, the current flowing through the lamp. And these two physical parameters can be measured using voltmeter and ammeter. So voltmeter should be connected across the lamp or in parallel to the lamp, whereas the ammeter should be connected in series with the lamp. So option B is the right choice, because you can see in option B the voltmeter is connected in parallel to the lamp and the ammeter is connected in series with the lamp. So these two devices will measure the two physical quantities, voltage and current, and after the power can be calculated by multiplying these two physical quantities. P is equal to VI. Okay, so voltmeter in across the lamp and ammeter in series with the lamp is the correct choice, and the option B. Question number 5. A 6-volt battery is connected to a network containing 5 identical resistors. A voltmeter has one lead connected to point K as shown. At which point should lead be connected so that the voltmeter reads 3 volt? It is point A. Okay. What is the explanation of this whole circuit? Here you can see the lead L. If we connect the lead L to point K, then the voltmeter will show 0 volt because point K and point L are at the same potential. Okay, between point K and D there is one resistor available. So 1/3 of the input voltage will drop across this resistor. So if we connect the point L with the point D, then the measured voltage will be 2 volt. Okay, now if you see there are two resistors between point K and point C. So 4 volt will be dropped between these 2 points. So if we connect the lead L to point C, then the voltmeter will show 4 volt. And if we connect the lead L to point B, then full 6 volt will be measured by the voltmeter. Okay, now in the upper branch, if you connect the point L to point A, then half of the voltage will be dropped across one resistor and half of the voltage will be dropped across another resistor because all the resistors are identical. So at point A, the voltmeter will measure 3 volt, and that's our correct option, point A. Question number 6. A potential divider is connected across the terminals of a 6 volt supply. When R is adjusted to 6 ohm, the voltmeter readings V1 and V2 are equal. What happens to the reading when the resistance of R is then increased? Okay, if we increase the resistance R, then more voltage will drop across that resistance. So in this case, the voltmeter V2 will measure increase in voltage, whereas voltmeter V1 will measure decrease in voltage. Reason is total input voltage is 6 volt, and this 6 volt will be divided among these two resistors according to voltage divider formula. So if the value of R is increased beyond 6 ohm, so more input voltage will be dropped across R and less input voltage will be dropped across 6 ohm resistor. So V1 will measure less voltage, so whereas V2 will measure high voltage or large voltage. So option B. Question number 7. The diagram shows a circuit. Which circuit diagram shows the circuit? Okay, if you see the diagram, two cells are connected in series and two lamps are connected in parallel. Now if you carefully look at the choices, then only choice A and B are showing the two lamps connected in parallel. So either A choice or B choice is the correct option. Now if you see the polarity of B, its polarity of two cells is wrong. Left polarity is plus and right polarity is also shown as plus. So it's a wrong polarity for two cells. For option A, the polarity of two cells is correct. The leftmost cell is negative. The terminal of leftmost cell is negative and the terminal of the rightmost cell is positive. So option A is the correct option. Question number 8. The diagram shows three resistors in parallel. What is the combined resistance? We can find the combined resistance using the formula 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, because these three resistors are connected in parallel. So 1 over R is equal to 1 over 15 plus 1 over 30 plus 1 over 30, and it is 4 over 30. By inverting these two equations, by inverting this equation, R by 1 is equal to 30 by 4, and that is 7.5 ohm. So option A. Also, if you look at the circuit diagram, then you can see two 30 ohm resistors are connected in parallel. So their resistance will, combined resistance will be 1/2. So combined resistance is 15 ohm. And now 15 ohm is in parallel with 15 ohm. So their combined resistance is 7.5 ohm. So by just looking at the circuit, you can also conclude or reach the conclusion that the combined resistance is 7.5 ohm. Okay. Question number 9. In which circuit is the voltmeter reading 7.2 volts? It is a simple voltage divider circuit. Input voltage is 12 volt, and this input voltage is divided among two resistors, and we have to find the value of the voltage in the lower resistor. So using voltage divider rule, for option A, the 5 ohm resistor is in numerator because we are measuring the voltage across this resistance, and the sum of the two resistors 5 plus 3 is in the denominator. So 5 over 8 multiplied by 20. So the voltmeter will measure 7.5 volt. For option B, the voltmeter is connected across 6 ohm. So put the 6 ohm in numerator, and the sum of two resistance 6 plus 4 is equal to 10 in the denominator. So this is the ratio. 6 by 10 is the ratio. According to this ratio, the input voltage will be divided. So 6 by 10 multiplied by the input voltage, it is 7.2 volts. So option B is the correct option. Similarly, you can also find the voltage measured in option C. It's 8 volt, and in option D is 9 volt. But option B, 7.2 volt, is the correct option. Okay, question number 10, the last question for this session. The diagram shows a circuit. Where must an ammeter be connected to measure the smallest current? Okay, so here the portions of the whole current flow through parallel branches or resistors. The whole current is flowing through part A and point D, and this whole current will be divided in parallel branches. So some part of the whole current will flow through branch B, and some part of the whole current will flow through branch C. Now you can see that the branch C has higher resistance than the branch B. So less current will flow through branch C and more current will flow through branch B. So smallest possible current will be a 20 ohm resistor. So option C.